9.4 Angle Sum Theorem. I can use the Angle Sum Theorem to help to solve the four missing angles.
Very clear, Mark. Thank you. Angle Sum Theorem, yes. Can we use it to find missing angles?
Yes.
Above and beyond, we use it to find the interior angle sum of any polygon, right?
Yes.
All right, so it's really important that we understand what a polygon is, and I think we define it really well in number 1. Interior and exterior angles is, I think we're okay with, right? 3A is just to prove that you could solve for interior and exterior angles. We did a little example on our scratch paper, or I did it on the sideboard. The Angle Sum Theorem is what we really need to know. You need to, like, this has to be memorized, like, as of now. It's on our cheat poll already, 180, which is the measure of a straight angle, right?
Yep.
So then n would be the number of sides of any polygon, subtract 2 and multiply it by that 180. Yes, no?
Yes.
Hypotenuse and leg. Let's look at the diagram here. Hypotenuse is opposite the right angle of a right triangle. Mahad, eyes up here. And then the legs make up the right angle. We cool with that?
Yes.
We didn't talk much more about that, but we're going to. All right, number 7. You needed to solve for x, right?
Yes.
In order to solve for x, you need to know how much each of these 3 angles add up to, right?
Yep. Yes.
So then what we did is we created a t-chart, and we used the Angle Sum Theorem, which is 180 times n minus 2, which we just talked about, right?
Yes.
How many sides make up a triangle?
3.
So we plugged in 3 for the number of sides n, right?
Mm-hmm.
What's 3 minus 2?
1.
What's 1 times 180?
180.
So we know the angle sum of a triangle is 180, yes, no?
Yes.
All right, and then what we did is we solved mathematically. We knew 2 of the 3 sides. We had to solve for x, yes, no?
Yes.
If you want to use algebra, you can. Or if you just want to subtract the 2 sides that you know, cool as well. Ended up with 49 degrees. Moving on, yes, no?
Yes.
Number 8. Looks like we have an octagon.
Mm-hmm.
And again, in order to solve for x, I gave you some information here. Ooh, whoopsies. My eraser went off. Hold on. Okay, I gave you, you needed to solve for x, right?
Yes.
I told you that 6 of the angles were 135 and 1 of the angles was 134. Is that a regular polygon, by the way?
No.
No, because we have different angle measurements, right?
Yes.
Okay. And then to solve for x, the first thing we need to do is figure out what is the angle sum. So this plus 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 this, all of the angles total what?
1080.
1080. And then what we did is we took all the angles we knew, so we knew 7 of the 8, totaled them up to get 944, ended up with the last angle being 136. Is this making sense?
Yes.
Okay. Last thing I want to talk about then would be what a regular polygon is. It has all of the same angles and all of the same sides. Okay. So then if I asked you the angle sum of a regular polygon, or just in any polygon, this is what we use our formula. Yes, no?
Yes.
Moving down to number 11, then you realize that number 11 was dealing with what kind of triangle? Regular triangle. So therefore, we calculated what the angle sum was of a triangle, which you're all going to know forever now, right? You're probably never going to have to do that again. And then since it's a regular, this angle and this angle and this angle are all what?
60.
They're all the same, which is what? 60. So we could just divide by the 3 angles that are in there. Yes, no?
Yes.
And then the sides, they're also all the exact same. Got it?
Yes.